Welcome to Brain Vision.
We're told that we're dealing with the atom bismuth, so the Z value is equal to 83. And we're told that we are going from the M to L orbital, so in initial, n sub I is equal to 3, and in final is equal to 2. And the equation that governs the energy of these different levels, E is equal to Z squared divided by the energy level squared times 13.6 eV with the negative sign out front. So that negative sign is going to be important. So for the Z equals M shell, we can call this Z sub M. We have, this is going to be equal to our original value, 83, so Z, minus 9, because we have 9 electrons, 2 from the K, and then 7 from the partially filled L. So that gives us 7 minus 9, or in other words, this gives us a value of 74. And then for the L shell, Z sub L, we have our Z value, 83, minus 2 from the partially filled K shell. So we only have the partially filled K shell this time. So Z minus 2 gives us 81. So now to find the change in energy, which is part A, we find delta E, which is equal to the energy from the M shell, E sub M, minus the energy from the L shell, E sub L. Well, both of those energies are going to have the 13.6 electron volts, so we can go ahead and pull that out front. As well as the negative sign. Both have the negative sign, so let's pull negative 13.6 eV out front. And then this gets multiplied by we got rid of the negative sign, so Z sub M squared divided by the initial value, n sub I squared, minus Z sub L squared divided by n final squared. So carrying out this operation, we find that the change in energy, delta E, is equal to 14 electron volts, or 14 times 10 to the third electron volts, excuse me. You could also write it as 14 kilo electron volts, but I'll write it as 14 times 10 to the third electron volts. We can box that in as our solution for A. Part B wants us to find the wavelength associated with this energy difference. So that comes from the equation that says that lambda, the wavelength, is equal to Planck's constant, h, times the speed of light, c, divided by the change in energy, delta E. So for Planck's constant, we're going to use the electron volts seconds version of it, so 4.1357 times 10 to the minus 15 electron volt seconds. Speed, the speed of light, is in meters per second, and then the delta E value from above gives us a wavelength of 8.88 times 10 to the minus 11 meters. We can box that in as our solution for B.